Hi, this is Dr. John Bergdorf. In this video, we're going to explore just a few examples of Venn diagrams. We're going to, first of all, use a Venn diagram to illustrate A intersection B complement. So since we have two sets, what we're going to do is we're going to draw a rectangle to represent the universal set, and then we'll put within that rectangle two sets, A and B. And then we'll explore how we're going to actually create the Venn diagram. So in order of operations of sets, complements come before intersections. So the first thing I need to do is look at B complement. B complement means everything that is, all elements that are in the universal set but are not in B. So let's see if we can explore that. All the elements that are in the universal set that are not in B. Let's shade those, maybe using a different color like red. All the elements that are in the universal set but are not in B would look like this. And I'll just make a little note over for myself over here that B complement is in red. And then I'll be looking at A intersected with B complement. So intersection is the set of all elements that are both in one set and the other. So we're looking for those regions that are both in A and in B complement. That would be right in here. These elements are in both A and B complement. And I might even consider rewriting this in a cleaner way. So let me draw a new fresh diagram here for my final result. Again, I'll put my A and my B. And the region that I'm looking at is this region. We'll color it in real nice. That would be A intersection B. Okay, let's do one with three sets. A intersection B minus C. So with three sets, you have to make sure your Venn diagram is big enough to represent three sets. And so we would have a set A, a set B, and a set C. A, B, C. Now, like in all the rest of mathematics, parentheses means do this first. B minus C, that's a relative complement. It means all elements of B that are not in C. Let's write those like this maybe. All the elements of B that are not in C, or another way to say that more casually is take the set B and take away any elements that belong to C, any areas that belong to C. That would look like that. A, we can see plainly, and the intersection of A with B minus C, where those would be in common, will be just this area right in here. And that's it. Just that area. So we'll shade that in really well. And that would be A intersection B minus C. You can use Venn diagrams to prove set statements, set theorems. The way you could prove that the complement of A intersection B is the same thing as the union of the complements of A and B would be to draw a Venn diagram for each of those. And if those sets are indeed equal, then the Venn diagrams will look the same. Let's see if that would happen. So let's first of all draw a Venn diagram for A union B complement. Oh, excuse me, it's A intersection B. Sorry. A intersection B complement. Well, we only have two sets this time, so that's a little bit better, I guess. We have A and we have B. A intersection B are the elements that are in both A and B. So that would be right in there. That's A intersection B. Let me write that a little cleaner. A intersection B. The complement of that would be all elements of the universal set that are not in A complement or A intersection B. That would be everything else besides what you see in red there. That would be all of this. So everything we're seeing in green. All through here. All of this would be A intersection B complement. Everything except that little football shape in the middle. Now, on the other hand, let's also draw a Venn diagram for A complement union B complement. And this one may take a little bit more work to make it look good. Let's draw our Venn diagram. A, B, like that. A complement would be everything outside of A. All the elements in the universal set that are not in A. So that would be all the regions outside of A. Like that. B complement would be all the regions outside of B, all the elements that are not in B. So that would look like this. All the elements not in B. Draw that like this. And then finally, the union of those two would be the collection of all the elements that are both in A complement, that are either in A complement or in B complement. In other words, it would be anything that has any shading at all. Let me do that in gold, maybe. A intersection, union B intersection. And that would be anything that is colored in any way. That would include all of this, and all through here, all the elements that are either in A complement or B complement. And if you look at the end result of these two Venn diagrams, on the left we had all that green area. So that would be everything except that football shape. And on the right, we have all that gold area. That would also be everything except that football shape. Just make sure here, this is in green, this is in gold, but the regions that are shown are the same. And that would prove that those two sets are equal.